Hello, I'm Michael Nonacool, a senior test lead within the Windows Core Networking team, and welcome to NDIS driver testing and certification. This is part one of a three-part series where we'll delve into how to test your NDIS drivers and how to get them certified. So in the first part, we're going to cover how the LAN tests are integrated into the Windows Hardware Certification Kit. We'll follow that up in part two with some test improvements that we've made to the tests themselves. And finally, in part three, some tips and tricks about how to debug NDIS test breaks. So networking that just works great is essential for customers to have great Windows 8 experiences. And these Windows 8 experiences could be client experiences, whether it's power or performance, or server experiences with hosted or private clouds. The bottom line is networking just has to work, and you're a big part of that story. So first we'll go into the Windows Hardware Certification Kit and what's special about LAN tests. We listened to you about the LAN certification tests in the Windows HCK. We wanted to make them easier to run. We wanted to increase the reliability and the effectiveness. Now your feedback here is critical. Anytime you give us feedback about the test failures or about mini port failures, we can incorporate that into changes in our test collateral to make them run better and to catch new bugs, which only serve to benefit our customers. We also wanted to optimize runtime. We realized that with Windows 8, we'll have new features for NDIS and new features for NDIS mini port drivers, and of course new tests come along with that. Now, in all cases, we wanted to reduce the overall runtime of the certification tests to make the process as easy for you so you can expedite shipping drivers to OEMs to package them for our customers. The tests are easy to automate and easy to debug. So, in keeping with the simplicity theme, I want to talk about the LAN test topology. The test target lives in the test client machine and is connected back to back to another device on the support machine. There's a back channel switch involved, and all this should be pretty familiar to you if you've used the WLK 1.6 for the existing Windows releases. Now, the back-to-back connection is key here. We removed an actual switch connecting the two devices together, and we had to do this for a couple of reasons. There's a couple of tests that send layer 2 packets. These are Ethernet pause frames, priority flow control frames, LLDP frames, and layer 2 switches are not able to forward those packets. So they would interfere with some of the tests for some of the new features. Other tests send 802.1q tag traffic. These could be VLAN tests, some of the VMQ tests do this, priority tests, and a few others that unless you had a switch set up explicitly on dedicated VLANs, it would be very difficult to run those tests through a switch. So we just got rid of it and made it easy to connect machines back to back and hopefully reduce a lot of the failures and a lot of the noise that you'll see during the tests. Now there's an alternate LAN test topology, and this isn't required for everybody. I've highlighted the changes in red from the previous screen. Now first you'll notice that a test switch was introduced. We added more links and more adapters to this test. Therefore, we needed a switch. A back-to-back connection wasn't possible. Now, the first thing you'll notice is that there's another link from the test client to the test switch. We'll refer to this as the local support device. The local support device is only needed if you run TCP connection offload tests or chimney tests. If you don't support that feature, the local support device is not necessary. The other big change is the storage. So some features like RDMA and QoS, or data center bridging, require some type of network-based storage in order to adequately test the feature. So we introduced this storage, which could represent Fiber Channel over Ethernet, or iSCSI, or some SMB share, which may actually be on the support machine. Nonetheless, network-based storage needs to exist for some of the QoS tests. And now we'll show a demo of how to actually launch LAN device tests from the Windows Hardware Certification Kit. So here we are in the new Certification Kit UI, and the first thing you'll notice is that there's a lot of clutter that's been removed. The UI is completely streamlined to show you only what you need when you need it to run the tests required for certifying a test target. So I'm not going to go into all of the details about the entire UI. There's a whole separate session about the Certification Kit, but what I am here to explain are how the LAN tests differ from other tests within the certification kit, and to give you an example of how to run the LAN tests. So first off, you'll have to create a project, and once you select the project, you'll have to select your test target. So coming into the selection UI, the first menu here is a drop-down list of machine pools. And a machine pool is nothing different than a logical grouping of machines involved for a specific test. It's not a new concept, it's been around since WK 1.0. I've created a machine pool for LAN, and you just saw our two test topologies. I've moved two machines into the LAN machine pool. So by selecting that pool, my two machines show all of the devices included that could be potential test targets. And you'll see I have this 105 machine in the machine pool and its respective devices, and I also have this 106 machine in the machine pool. So I'm only going to select the test target or the device that I'm interested in testing today. And in that case, it's this network adapter. So by selecting the checkbox, behind the scenes, what has happened is a gatherer has run on these machines, and the gatherer has detected what features this particular device supports. In order to see those features, you can right-click on the device and view a list of features that the gatherer has detected this device supports. And you'll see that in this case, some of the device fundamentals features are detected. And if I scroll down lower, because I selected a networking device, you'll see some of the network features have been detected as well. We use BASE as essentially the LAN device fundamentals test, all of the basic requirements needed for any Ethernet device. And you can see some of these advanced features for Windows 8 devices are listed here, not necessarily supported by this device, but if the gatherer made a mistake, you can always double check it here and manually select a feature if you'd like. So I'm just going to click OK and move on to the test section. Now the test section displays a list of jobs that test all of the features that the gatherer detected. And first off, before we schedule any test, let's take a stroll back down memory lane and remember how this worked in the old version of the Windows Logo Kit. In the old version, when you selected a test and tried to run it, a pop-up screen would come up and ask you for more information about how to run this test. And the pop-up screen would ask you things like what other machines are involved in the test, what the local support machine is, and what other devices are involved in the test, and what their role was. It would have asked you what is the message device, what is the support device on each of the machines involved, and that's a lot of selecting and a lot of clicking for each test that you try to schedule in the UI. So in Windows 8, we've made this more automatable by defining some static names that you can change the network interfaces to be to identify which interface plays which role in the test. We have standard names for support devices, standard names for message devices, so you can set up your lab, change the IF aliases of these interfaces, and the tests will automatically pick them up and determine their role. To make it even easier to detect the IF alias, we've created a job called Configure Network Devices for LAN Testing. Now it will go and auto-detect which devices could play the role of a support device and which devices could play the role of a message device. Now message devices are simply detected by whether or not a DHCP address was assigned. And a support device must meet some real basic minimum criteria. For Ethernet, that's medium Ethernet, physical medium Ethernet, no DHCP address, and it must be media state connected. So you could run this test on your machines involved, and that will go automatically rename the IF aliases. The main point is the IF aliases must be renamed or must be named either manually by you or by this job prior to running any other job. So the next thing you'll notice is a bunch of granular tests here. And I'm just going to go and pick one called Check Connectivity, which is a simple connectivity test, and demonstrate how to launch a test from the new certification UI. I'll click Run Selected, and immediately a pop-up comes up. Now we still need to know a little bit of information about how to run this test. Here you'll see that there are two roles possible for this test. There's a client role and a support role. The client role is the role of the machine that has the test target. And you can see that this machine, which houses the device that I selected, is automatically selected to be the client role. This is the default role in the job. The other machine that's part of our LAN test topology is the support machine. And this UI will list a list of machines that are available in the machine pool. Now, I only configured this machine pool with 2 machines in it, so the other machine, the 106 machine, is listed here. And I'll select that, click OK, and now the job is scheduled and running. Now you'll notice that in this UI, once the job gets scheduled, an hourglass shows up, and you can check down here for status of the run for this particular job. Now, let me get back to the granularity of the jobs. We broke up all of the NDIS test 6.0 and 6.5 jobs into granular tests for each individual NDIS test script. This allows you to rerun tests that may have a transient failure or an intermittent failure without having to rerun the entire suite of the tests. It saves you time, saves you energy, and a lot of the guesswork is taken out about whether or not the test will succeed. So the next test I'd like to draw your attention to is a test called Cross Storage Interop Test. This is a test that leverages the alternate LAN test topology where a network-based storage device is present. And the reason I wanted to draw your attention to this test is that when you run this test has custom parameters that must be filled in. And this UI will show you. Now, this down here, the machine role, was familiar from the check connectivity test. You can select the support role and you can select the support machine, as we mentioned earlier. But in this particular test, there are additional parameters that the test needs to know in order to run correctly. In this case, it needs to know what type of storage it is, whether it's fiber channel over Ethernet or iSCSI or network direct, which means some sort of SMB share. And then the storage must be mapped to a particular drive letter, so the test can do storage I/O writes to that drive in order to validate the functionality. One thing I would like to mention is that if you select multiple tests and try to run them simultaneously, you don't have to select the machine role for each individual test. As long as you run all of the jobs in the same schedule and they have similar machine role requirements, all of these jobs have the same client role and support role, you'll only have to make the machine selection once, and that will reduce the clicking that you need to do in order to schedule these tests. So you get the benefit of granular tests without any additional tax of additional clicks. Now finally, I want to show you the results viewer where you can check on the status of currently running or previously run tests against your test target. Here you can see that we were running the NDIS test check connectivity test, and you can expand the test to see all of the particular tasks in that job and whether they've passed or failed, and you can delve into any of the test results from this user interface. Now, hopefully in a minute we'll see it all pass. So here you'll be able to look at the WTT log file from any of these NDIS test tasks and triage issues, debug failures, do whatever you need to do to debug this problem. It's a neat and tiny little view to look at the summary of all of the tests that have been run and all of the tests that have passed and all of the tests that have failed. There we go. So now we can see that all of the tasks as part of this job have passed, and you're done. You just saw a demo of how to run the LAN test in the Windows HCK. Now, a couple of things that I'd like to mention so you can plan your test labs accordingly. It's been a little ambiguous in the past about what type of hardware people should procure to build out their labs. So I wanted to be more explicit about some of the requirements that you need to have for the hardware involved on running these tests. If your device supports RSS, we require you to have more than 4 physical cores. This is needed because Windows 8 supports RSS indirection tables of non-group 0 CPUs, which means the test will artificially set the group size small, and we need enough cores to populate a second processor group. The next requirement is that these machines that run the tests must be able to saturate 90% of the maximum link speed of the network adapter. This is because some of the QoS tests test bandwidth reservation, and in order to test bandwidth reservation, we need to fully saturate the link in order to make sure that the algorithm is doing the right thing. So we've set the bar pretty high at 90% of the maximum link speed. Now furthermore, The quas tests require storage that's capable of writing at 20% of the maximum link speed. This means if you have a 10 gigabit network adapter, the storage that's network based must be able to be written to at 2 gigabits per second or 250 megabytes per second. We need to do this so we can adequately detect failures in the minimum bandwidth algorithms. And finally, for SRIOV, it should go without saying, but SRIOV devices require to be run on SRIOV machines, which means you need to work with OEMs to ensure that the latest PCI spec is being honored and they have the latest firmware to enable I/O virtualization. The most important thing that we improved in the Windows HDK, we're breaking out all of our jobs into more granular versions. You noticed in the demo that the NDIS test 6.0 and 6.5 jobs were broken out into the individual test scripts. This is really beneficial that we've heard from customers in order to reduce rerun time when an individual failure happens. Now, in order to do that, we had to make sure that we reduce the costs of clicking through the UI so it's not any additional burden to you when scheduling these tests. So we created the custom parameter and machine configuration expansion feature to ensure that at schedule time, it's the same number of clicks no matter how many jobs you schedule to make it easier on you to run these tests. The Windows HDK includes an object model, so you can program your own code to automate all of your tests in a lights-out lab and expedite your certification process. And the last thing that I can't stress enough is that lots and lots of reliability improvements have been made in NDIS test to reduce the number of failures, to reduce the number of errata. In some cases, we've made tests more lenient, and in some cases, we've made tests more stringent. But in all cases, we've improved the reliability and the effectiveness of the tests. See the related sessions on the Windows HDK. For further reading and documentation, see the HDK documentation, visit us at our NDIS blog, or contact us here. So hi, I'm Michael Nonakul, a test lead in the Windows Core Networking team. Welcome to part 2 of a 3-part series about NDIS driver testing and certification. Networking that just works is essential for customers to have great Windows 8 experiences. These experiences range from client experiences, whether power and performance are key, connectivity is key, or server experiences if you're deploying private clouds or hosted clouds. It all boils down to networking that just works great, and you're a big part of that. In this section, we'll talk about LAN test improvements and things that we've done to help test the Windows 8 features. Run the LAN certification test early during driver development, not just during certification. The tests are manually downloadable from installations of the certification kit and of the development kit. Getting the test binaries has never been easier, and you should run them early and often to find issues early, fix issues early, and streamline certification. Now I want to cover some of the new features that we've added in the Windows 8 tests. Now these features aren't an exhaustive list of all of the NDIS or mini-port features in Windows 8. Rather, they're just some of the highlights or the big areas that we've made key investments in to validate these features that our customers depend on. So the first feature is the quality of service or data center bridging feature. Now this introduced some new challenges for the test team. The whole feature is surrounding minimum bandwidth allocation, which means that the tests need some way of sending traffic at line rate and monitoring traffic to make sure that the bandwidth allocations are honored properly. We've introduced a new lightweight filter that must be installed on the NDIS test server machine. Right? This lightweight filter is called PCOP, and it's available with NDIS test, but it's one extra manual step you'll have to run on the server if you choose to run these tests manually. In order to saturate the link at line rate, we utilize TCP/IP as opposed to the NDIS test protocol. We did this for a couple of reasons, but mostly because we wanted to utilize the link how an actual end user would utilize it through WinSock and not through NDIS test. So we use TCP/IP, which also takes advantages of large send offload and checksum offload and receive side scaling on the receive side to saturate the full link. The next set of tests I want to cover are single root I/O virtualization. These are also implemented within NDIS test as NDIS test scripts. So these tests require a couple of new drivers that plug into the I/O virtualization subsystem. They also have specific sets of tests for the PF and for the VF. And these tests you'll find in new job groups that are included in ndistest.net in the certification kit. The next set of tests are called RDMA tests. Now these tests test SMB Direct and the kernel mode RDMA interfaces that you're going to be implementing in your Miniport driver. These tests are standalone tests. They're not part of NDIS. They include new drivers that connect into the kernel mode RDMA subsystem in order to better test your driver at the boundary conditions for the Miniport interface that SMB can't normally do. So SMB includes some error checking. It includes some error handling to prevent some of the error conditions or boundary conditions from being tested in your driver. And we needed to create new kernel mode drivers to make sure that your Miniports are as reliable as possible. The RDMA test will also include some end-to-end SMB stress tests to make sure that the actual customer scenario was tested across your Miniport. And lastly, I'll cover receive segment coalescing. Now this is a best effort feature where network packets on the receive side, TCP packets, are coalesced and indicated to the OS as one coalesced packet. Now we've had to create a new filter driver that runs on top of the test target in order to validate that the coalescing happens properly. The tests themselves will try to put the device or put the network in the best possible scenario such that coalescing will occur, and the filter driver will validate that coalescing occurs properly. The tests also introduce some individual test cases where sequence numbers are out of order or packets are missing or checksum is corrupt or something else that would prevent coalescing from occurring, and making sure that the coalescing doesn't occur in those cases. Some other new tests that you need to watch out for in the LAN tests for Windows 8 are listed here. Now these tests aren't related directly to a new NDIS feature, but they are related to Windows 8 features that all of our customers have been asking for and wanting to use. The first is standardized keywords. This is related to the Windows 8 PowerShell feature, where network adapters for the first time are able to be managed through PowerShell remotely, so IT admins can control their entire data center from a network management standpoint from one console. Standardized keywords are important because we need to maintain a consistent interface for all IT admins to manage network Miniport drivers. The keywords have been documented on MSDN for a long time that have standard nomenclature for names and for values and for the location in the registry. And all of that is key for you to implement such that we have a consistent manageability story. The next set of tests are generic NDIS Miniport tests. These tests run on any NDIS Miniport, whether they be LAN or WLAN or mobile broadband or a virtual Miniport enumerated from an intermediate driver. These are very simple tests that validate basic requirements like the NDIS version, and now a new requirement that you don't use various characters in your interface description. The example that I typically give is the backtick character that may break PowerShell manageability. So offload parity will increasingly be an issue moving forward. IPv4 address space has been exhausted, and all of our customers are moving to IPv6. We need to make sure that your devices and our operating system have parity when it comes to features and performance between IPv4 and IPv6. So we've included tests to make sure that IPv6 is an equal citizen to IPv4 when it comes to supporting all of the performance and new features that Windows 8 delivers. The last two I'll talk about together, power requirements and Wake on LAN. Now I'll use this as an example of a model of how we've changed a lot of the LAN certification tests to separate the requirements from the actual functionality tests. In the requirements tests, we'll take a look at the capabilities that you advertise to the OS and make sure that they correspond to the requirements that we have for certification. For Wake on LAN, they would be things such as 8 patterns or ARP and NS offload and the like. The tests themselves just run the functionality tests based on what capabilities were advertised. And in Windows 8, the Wake on LAN tests have been completely rewritten. They've been rewritten to reduce the number of test cases while keeping the effectiveness up. Runtime is reduced 20 to 30%. And the biggest improvement is that Wake on LAN tests can now be run on a single machine. Now this is only available if you run the tests manually, not through the hardware certification kit. But if you run them manually and your device supports going to a D3 low power state while the system is still in S0, it is possible that the tests will just put the device into sleep and then send the wake packet from the local support device. Therefore, you can easily run wake on LAN tests in your office with a single machine, no back channel required. So I want to take a moment to talk about NDIS filter testing. We've gotten a lot of feedback from filter developers that we have a lot of test guidance around mini ports, but not so much around filters. So first and foremost, you can use the NDIS test LAN tests in order to test your filter driver. Virtually all of the handlers that you register with NDIS and NDIS filter driver characteristics are executed by running the LAN tests. Simply install your filter on top of a LAN device and run the LAN tests. If your filter driver intercepts any particular OID or any particular type of traffic, you can start by using targeted NDIS tests for those things. If your filter intercepts, for example, IP traffic or IP TCP traffic or IP UDP traffic, then you could run the RSS tests, for example, because those tests generate traffic, IP-based traffic, v4, v6, with a ton of headers behind it to make sure your filter driver handles those properly. A new type of filter was introduced in Windows 8 called the Hyper-V Extensible Switch filter. Now you can plug in modules that sit within the Hyper-V Extensible Switch, and we're going to have new test cases around that. These will utilize virtual mini ports and the inbox TCP/IP stack to validate that your filter abides by the public documentation about what it can and can't do for that filter type. I want to tell you to focus on plug and play. So we've seen in our experience a lot of issues that come up during some sort of PnP event. This could be an NDIS stack pause and restart, or some sort of status indication, whether it be a link speed or a link state indication or a network change status indication, while a filter driver or some other module in the stack is handling traffic that they care about. So if you care about, for example, IPsec traffic or some kind of TCP traffic, and the link goes down, or another filter gets inserted in the stack and the stack gets paused, it's in your best interest to create tests around these areas to make sure that your filter can handle these sort of asynchronous things that happen in real life. And finally, utilize the device fundamentals test. Device fundamentals test a lot of basic system functionality like standby resume, stop-start of drivers and services and that sort of thing that every driver must adhere to. And running these early and often during driver development help weed out those initial bugs that can cause problems later. See our related sessions about network acceleration and the Windows HCK. And visit us on the NDIS blog or contact us at the alias provided. Thank you. Hello, I'm Michael Nonakul, a test lead in the Windows Core Networking team, and joining me is Anirudh Jahargidar, an SDED on the team. Welcome to part 3 of our NDIS driver testing and certification series. In this part, we're going to focus on debugging issues in NDIS test. Have you ever seen a failure in a test listing a protocol breakpoint where the protocol didn't actually break in? Or have you seen a stack trace like this that includes ndprod on the stack, but you have no idea why ndprod has asserted or what the problem is? Driver developers are now empowered to easily debug NDIS test breakpoints. And to really drive this point home, I'm going to turn it over to AJ, who's going to give you a demo about debugging NDIS test protocol.
Hi, I'm AJ, and I'm going to step into the debugger's shoes here and help you debug this particular dump. Now, this dump comes from an MPE test run. As you know, MPE is a multipath exerciser. It's one of the tests that we have in the Windows HCK. It's a stress test, and so what that means is it tries to exercise both the data and control path simultaneously. What that means is the test is going to put your machine in sleep states. It's going to do some data, networking, I/O, etc. at the same time. With the status quo, this is what you see on your screen. Not much information. All you know that there is a break, and that's it. There is no information about what the break is all about, who has broken in, etc., etc. So to mitigate this, what we have done is we have added the symbols into the NDIS test folder, and with those you will be able to get a view as to what just happened, right? So let's start by adding the symbols in this break. Alright, so the symbols are available in ndistest.net bin/symbols directory. So I'll just add that. And now let's reload the protocol driver symbols. There. Along with these symbols, what we have done is we have also added a new NDT-KD extension. NDT-KD stands for NDIS test KD. You can think about this extension as a cousin to NDIS-KD. With NDIS-KD, you get a view into the break from the NDIS's perspective. With NDT-KD, what you get is a view into the break from the test's perspective. So let's start by firing the obvious command here, which is help. And as you can see, the NDT-KD extension is also available in the NDIS test folder under bin KD. There. So let's see if this break is an assertion. What an assertion is literally a KD assert put in the protocol driver. Normally, an assertion means that it's an unrecoverable error. It could be caused by either the protocol itself or because of a misbehaving miniport driver. We just don't know. All we have to do is fire this command to see if there were any assertions hit. Good. So there were no assertions. Now let's see if there were any breakpoints hit. Now what a breakpoint is essentially a sanity check in the protocol driver that checks to see that whatever is happening, the current action from the test's perspective is alright. The sanity checks are put in the PNP path as well as in the data path. Not all breakpoints are the same. Some breakpoints are more important than the other, and that might change from test to test. For a given test, a breakpoint may be important, but for some other test, that may not be as important. We'll see in another demo how that behavior can be changed. So let's just fire this command. Oh, looks like we hit two breakpoints here. The current breakpoint is this one, and looks like there was one more breakpoint hit, which is this one. Notice that the first breakpoint that you see in this list has been hit for 624 times, whereas the second breakpoint that you see here has been hit only once. This tells us that this breakpoint, although hit so many times, was not as important for the protocol driver, and therefore it did not result in a break. Whereas the second breakpoint was quite important. It was hit only the first time, this time, and it resulted in a break. One of the things that you should remember here is that this list is in order of the occurrence of the breakpoints. Meaning, the first breakpoint that you see in this list is the first breakpoint that ever occurred when you started this test run. The second breakpoint followed the first one. Right. So we have some information now about the break. Now let's see if there is some extra information. Let's see if there are any spews. Firing this command is important in process of triaging a break because there could be some messages that are spewed by the test or the protocol driver that may lead us to this break, and these messages may not be assertions or breakpoints. So looks like in this case there are no extra messages that are useful. Let's see what the stack looks like. There. So on the stack we see that there is a send thread that's running which has caused this break, and reading the last break message would tell you what's going on. Okay, so let's move on to the other demo. this demo, what we are going to demonstrate is how to enable the breakpoints that are not enabled by default in the kernel mode. Let's look at this test, for example. Invalid packets test seems to have failed here. Let's open up the HTML log file. Looks like there was some breakpoints hit, right? And remember that this is quite similar to what Michael showed in the slides before. To enable these breakpoints to be hit in a protocol driver, so let's open View, Options, NDIS test protocol, and select all the breakpoints available here. Normally you would see only fatal is selected. If you select rest of these, this will result in a protocol driver break. I'll click Save and hit Start. What we expect is the protocol driver to break in as soon as we hit the first breakpoint. Looks like we have already broken in. Great. So as you can see, now you get an opportunity to break in with B. Now that we have hit B, that has resulted in a debugger break. I have already set up symbols here. So now let's just look at the stack. There, we have ND protocol on the stack, and you can continue triage from here.
You just saw the demo, and I'd like to reinforce that you use the NDIS test protocol options to manually debug the breakpoints that occur during tests. You can leverage the public symbol files and the new NDT-KD debugger extension for debugging kernel mode assertions. NDIS has WPP tracing. A lot of people don't know this. It's a little known kept secret. You should visit the NDIS blog to utilize the NDIS WPP tracing in order to debug mini-port initialize or control path errors that commonly occur and may leave you wondering what's happening in NDIS. NDIS KD has also been enhanced to allow for easier debugging by dumping NDIS internal structures for the mini-port driver, for filter drivers, for opens, and many of the advanced features within mini-ports so you can understand what NDIS thinks the state of your driver is. Now there's also an NDIS KD command for dumping out the current net buffer lists that are associated with a driver on the stack. Now this is very, very helpful for debugging problems such as send completion problems or waiting for net buffers to be returned on the receive path. In this case, NDIS tracks which driver in the NDIS stack holds on to a net buffer list at any given time. Now this tracking is enabled by default on client SKUs, and on server SKUs you'll have to set a registry key to enable it, but it's very, very powerful in debugging why pauses take a long time or any type of MBL tracking issue. See our related sessions at the Build Conference, and visit us at the NDIS blog for more information about NDIS WPP tracing, the NDIS KD extension, and contact us at the address specified. Thank you very much.